Hello students, today we will discuss about series combination of capacitors and parallel combination of capacitors. In series combination, as shown from this figure, capacitors are connected end to end, and for this case, if we have a capacitor C1 and C2, then the equivalent capacitance will be C1 C2 by C1 plus C2. On the other hand, if we have those capacitors in parallel, so that their two terminals are connected together as shown from this diagram, we have C1 and C2 connected this way, so that if the equivalent capacitance becomes C, then the C should be C1 plus C2. So these are the formulas. Now we must know that if these formulas are correct from the experiment, it should supported by the experiment. Now let's take some known values of C1 and C2. So for C1 and C2 being 100 picofarad, farad is being the unit of capacitance, and the equivalent capacitors in the series connection, it will be, C should be, from this mathematics you can find, it should be 50 picofarad, right? So in the series combination, capacitance actually decreases, total capacitance decreases. Now in the parallel combination of those two capacitors of each with 100 picofarad, so the resultant capacitance, equivalent capacitance will be 100 plus 100 picofarad, meaning 200 picofarad. Okay, so these are the mathematics from the equations. Now we will see from the experiment that if these mathematics are valid, the experiment must support these so that it will be convincing. Now for the experiment, here I have a device which can measure capacitance. It can do many other things, but we will not consider about those. Let's only focus on the capacitance value Cs as shown here. Now we are going to check one by one those capacitors which I have taken, and let's measure the capacitance value of first one, and it should be about 95.4 picofarad, which is around 100 picofarad. It is okay that there can be some error in measurement, but mostly it should be the specified value. So it's 100 picofarad. Okay. Now I will check other capacitor. Let's connect it by those two terminals. Now I will measure it. So now the capacitance is 95.5 picofarad, which is again 100 picofarad equivalent. So we have those two capacitors of about 100 picofarad each. Now I'm going to connect and make a series combination out of those capacitors. So this way of making a series combination is slightly unscientific, but this can lead to some measurement error, but that's okay. For the quick checkup we can do this. And now I made a series combination of capacitance. So from the mathematics we know that this capacitance, equivalent capacitance should be about 50 picofarad. Let's see what comes from this series connection or series combination. We have to measure capacitance value, and it is about 47 picofarad, which is no less than 50 picofarad, as we got from the experiment. So the theory and experiment are agreeing each other. It shouldn't be so abruptly different that it will violate the theory, and this shouldn't be the case. Now I'm going to make a parallel combination quickly, and using those two same capacitors, here I'm going to connect it, and now I have parallel combined capacitors. Now I will make the equivalent capacitance. So from the mathematics, this has to be around 200 picofarad. Now I see it's about 190.2 picofarad, so which is okay. It's okay to have 10% or 5% error, but it should be followed by the mathematics. So the experiment and the theory are agreeing each other.